Hello everyone. We have this. I want to cover the topic of carbonatite, and it's a igneous pathology topic, and that I'll be doing. This is a PPT that is available on the Google itself, and the whole notes been taken from the JD Winter only, but in a crisp and precise form. Starting with the carbonatites. Carbonatites, they are the most undersaturated rock in alkaline province. उनको carbonatites कहा जाता है. इस पे भी क्वेश्चन आ सकता है. Second point is not important. The idea of magmatic carbonatites met with immediate opposition from Bowen, who thought that carbonates were of replacement origin. Also, carbonatites by definition, they contain more than 50% of carbonate minerals, and there is a table for carbonatite nomenclature. We have 4 types of them. We have calcite, we have dolomite, we have ferro, we have natro, and then in alternative we have coarse and medium fine grain. So in calcite carbonatite, coarse grain one is called sowite and medium and fine grain is called elvikite. Rogite is coarse grain and before site is medium grain. So carbonatites, I've already told you that. Although very few ferrocarbonates contain ankerite or siderite, they are typically fine grained of calcite and hematite. Natrocarbonate is very rare and it is known from only one volcanic center. So for carbonate bearing rocks, 10 to 50% carbonates, the IUGS recommends the use of modifying term calcitic dolomite before the igneous rock named on the remaining silicate assemblage. Silicocarbonate is a term that appears in literature for rocks for 10 to 50% carbonate, and carbonatite more than 50%. Carbonatite is in East African Rift. They early occurred in volcanic cinder cones, and as shell intrusive body, they were very high in sodium and calcium, and they contain sodium-rich pyroxene and calcium-rich and sodium-rich amphibole. Pyrochlore is niobium and tantalum-rich oxide mineral. So we have this table: submineral in carbonatite. We have calcite, dolomite, ankerite, siderite, strontianite, and we have many names are over here. These are the minerals that are present in carbonatites. So after this, the field characteristics. Carbonatites, they occur as volcanic or intrusive body. They commonly occur within or cyclic to alkyne intrusive centers, and they have areas that is less than 25 kilometers square. And are very composite. They have multiple intrusion of both silicate and carbonatite magma. So exposed intrusive carbonatites, they include the small plugs, cone sheets, and occasional ring dikes with planar dikes or dike swarms. The wall rocks may have fractured appearance, suggesting a high volatile content of carbonatite melts. Okay. And we have in this sequence, we have this this is idealized cross section of carbonatite alkaline silicate complex. Okay. And with early aeolite is there by aeolite cut by more evolved urierite. So aeolite is being cut by the urite. Carbonatite, most commonly calcitic, intrudes the silicate plutons, and it is itself cut by later dikes. Okay. Or cone sheets of carbonatite and ferrocarbonatite. The last event in many complexes, pods of iron and RE-rich carbonatites, a finite areole surrounds the carbonatite phases and perhaps also the alkaline silicate magmas. In this figure, there is a aeolite or nepheline cyanide plugs, and they have been followed by carbonatites that cut the earlier silicate complex. Sovites have typically over more than 90% calcite, and they're the most common carbonatite in these complexes. Okay, now the later manifestations of the igneous activity in many complexes is the emplacement of dikes or cones of iron-rich carbonatite, and they are collecting. Basically, they are telling us a story about this picture, how it is happening. And what is the final step? The final step is finely pipe-like bodies of iron and Re-rich carbonatites. Some are distinctively radioactive, may be emplaced. Carbonatite field characteristics. The last episodes are typically very brecciated and exhibit replacement and fluorine addition. So they appear to involve late stages fluids that may be hydrothermal in nature, and all of the stages are rarely developed in single locality. Estimated temperature of emplacement calculated from mineral geothermometry ranges from 550 to 1000 degree Celsius. Now, an almost universal characteristics of carbonatite complexes is the presence of distinctive metastomatic aerole. in which the wall rocks, most commonly called quartz of feldspathic gneiss, they have been converted to agrine-rich and alkali, amphibole-rich rock, and in some cases to potassic-rich rocks. So the metastomatic rocks are commonly called phennites, and they are the process of phenatization, and the name has been given after the phenalkaline complex in southern Norway. Phenatization begins along a network of fractures, and they typically involve the addition of alkalis and progressive desilicification, in which the original quartz and feldspar of the country rock are replaced by alkaline, pyroxene, and amphibole. The prevalence of such metastomatic rocks around carbonatite complex indicates that the large volume of alkali-bearing solution are given off during cooling. So, about it. Ancient intrusive carbonatites are composed predominantly of calcite, whereas modern ones contain more sodium carbonate. Rainwater rapidly dissolves the sodium carbonate, and it is not surprising that nitrocarbonated lava are unlikely to be preserved in geological record. One explanation is that carbonatite magma do indeed have the concentration of sodium carbonate, but during solidification on cooling, hydrothermal solution remove the sodium from the carbonatite, leaving it essentially of calcite only, and transporting the sodium to the country rocks to form phennites. Some carbonatites are of economic value because of the presence of ores of niobium and rare earth. And initially, carbonatites were mined only for iron and limestone, which is used for cement and as flux in smelting iron. Some carbonatite contain zones of high concentration of pyrochlore, that is namibium and tantalum rich mineral. And RE and thorium can also be present in economic concentration, mainly in perovskite, that is CaTiO3. Carbonatites as a group, they have exceptionally high concentration of titanium, niobium, zirconium, Re, Fe, FBa, Sr, and Th. So these elements are abundant in alkaline magma. In any case, but it appears that during the process of generating carbonatites, they are further concentrated perhaps through the strong liquid partitioning into an immiscible carbonate liquid. So there's a schematic diagram of asthenospheric mantle plume beneath a continental rift environment, and the genesis of the nephelinite carbonatite and kimberlite carbonatite. Okay. So we can see that there is a magma chamber that is formed, and the magma is coming नीचे से, and drift के नीचे we have nepheline carbonatite and filled kimberlite are there. उसके side में metastomatism forms the kimberlite ऊपर. So carbonatite Indian occurrences, so they are described from several mafic alkaline and nepheline cyanide complexes of different ages, like Mer Mundwara ring of intrusion of Sirohi, Rajasthan. We have Amba Dongar Srivisan alkaline complex of Gujarat, of post-Deccan Trap age, Alchuru Bora, Konavuram alkaline complex, Andhra Pradesh, and Nivania Pluton, Rajasthan of Precambrian age. So, if I would prepare a short notes for it to give you, that was a very in-depth knowledge from the J.D. Winter. So, petrogenesis of alkaline rock, that is carbonatites. I've already told you it has carbonatite. It is igneous rock that contains more than 50% carbonate mineral, and they are associated with alkaline rock suit. And silica content is less than 50%. That's why they are most undersaturated. Okay. Primary minerals are calcite, dolomite, anchorite, and accessory minerals are apatite, magnetite, pyrochlore, fluorite, and REs. Mantle source. So petrogenesis of carbonatite. Carbonatite originate from CO2-rich mantle source, often associated with mantle plumes and metastomite lithosphere. Their enrichment in volatiles CO2 and H2 promotes the generation of carbonate-rich magmas. Partial melting. So low degree of partial melting of mantle peridotite or carbonate eclogite produce primary carbonate melts. CO2 lowers the solidus temperature, allowing melts to form at lower temperature. Then carbonatites often do form by liquid immiscibility between the carbonate-rich and silicate-rich magma. So during cooling, the two magmas separate due to the differences in density and composition. Concentrating CO2, there is in one phase. Carbonatites may assimilate crustal material as they ascend, modifying their composition. Carbonatites can erupt volcanic flows into dust plutonic bodies. So tectonic settings. East African rift system, I already told you, in rift zone. Continental rifting is there, where lithospheric extension facilitates the mantle melting. Intraplate volcanism, that is related to mantle plumes and hotspot, where upwelling plumes brings the CO2-rich melts to the surface. That is all Donyo Lengai, that is there in Tanzania. And subduction zone, it's very rare. But metastomatism and subduction zone, they can produce carbonatite magma, though this is very less common. So geochemical characteristics. So they have very high calcium magnesium and CO2 content, and they have low SiO2. Trace element में they are very enriched in REDs, Ba, Sr, Th, and U, and they are depleted in Ti, Zr, and HF as compared to typical silicate magmas. They have isotopic signatures, ND-Sr isotopes. They indicate that they are metal derived source from limited crustal contamination, and CO isotopes reflects the interaction with metal derived CO2 fluids. Unique features are high RRE concentration. I've already told you they are the primary source of elements like Nd, La, and SCE. And liquid immiscibility, it's a hallmark of carbonatite petrogenesis. Volcanic carbonate, it's rare volcanic complex, but it is present. Economic significance, I've already told you, REs as well as fluorite, apatite, and niobium. And carbonatites are often spatially and genetically associated with alkaline rock complexes, that is nepheline cyanides. Classification of carbonatites. I've already told you the table. Here we have this, the rare one is not given over here. We have calciocarbonatites, magnesio, and ferro. And geochemical regions and discrimination. Okay. So we have Sr and Ba. The high value indicates the mental derived origin. NBU, THU, high ratios of mental metastomatism. And LB, LAYB, high values suggest a deep mental melting with garnetine residue. They are the places. And quick revision points, more than 50% carbonate minerals associated with alkaline soutes, most undersaturated alkaline rock, and a CO2 rich mental source, low degree of partial melting, liquid immiscibility is there, and it is present in rifts, hotspots, and plumes, high RRE content, association with alkaline rocks, and the hosts are economic importance is they host REDs, niobium, fluorite, and apatite. So that's all.